All right, it says, this is June 2017, question number 7. And it says, the table below shows the speed to the nearest kilometers per hour of 90 vehicles that pass checkpoints. All right, the first thing, N is equal to the sum of the frequency. So this must be what? 90. How many vehicles pass checkpoints? How many vehicles pass checkpoints? So how many speed did I record? 19. So you have a total of what? 19 values. N, which is the number of values, is equal to the sum of the frequency, which is 19. Next we are asked to A, for the class interval 20 to 39, complete the following sentences. I. So A, read A for me. The upper class limit is, so they're talking about for the class 20 to 39. 20 to 39. What would be the upper class limit? The upper class limit is 39 kilometers per hour. The upper class limit is 39 kilometers per hour. Please note, these values are the lower class limit. These values are the upper class limit. What does II say? What does II say? The class width. The class width is, now class width is equal to the upper class boundary minus the lower class boundary. For this class, what is the upper class boundary? For this class, what is the upper class boundary? It's 39.5. I really don't know nothing. What is the lower class boundary? 19.5. It is 19.5. The class width is equal to 20 kilometers per hour. To get the upper class boundary, you add 0.5 to the lower, to the upper limit. To get the lower class boundary, you take away 0.5 from the lower limit. Next, the third point says 17 vehicles pass a checkpoint at no more than 17 vehicles pass a checkpoint. 17 vehicles pass a checkpoint at no more than is it 17 it says? Pass a checkpoint at no more than. Alright. Between here and here is how much vehicles? 16. How many vehicles is this? 16. Fine. Yeah, I have an issue with it too, because he's saying what? 17 vehicles. Alright, let's just double check to ensure that we're correct. And then we're going to do something. Let's double check to ensure that that is correct. Then we're going to answer the question. And yours it's a 16? It's June 2000 and what? 17. Alright, get in there. Yes, it is 16. 16 vehicles. So as I said, this is what, 16 vehicles? Should be 16. Alright, so 16 vehicles pass the checkpoint with no more than what speed? No more than means less than or equal to. The first 16 vehicle, what is the highest speed they have? The first 16 vehicles, what is the highest speed they have? Talk to me. Let's see it. The first 16 vehicles are this. These are the first 16 vehicles. And the highest speed they have is what? 39. Alright, so I would say 39.5. Because 39.5 is what? Is the upper class what? Boundary. So 16 vehicles pass the checkpoint with a speed of no more than 39.5 kilometers per hour. The highest speed for the first 16 vehicles is what? 39.5. So those 16 vehicles pass the checkpoint with a speed that is what? No more than what? 39.5. That's the highest speed they achieve. No more than is an inequality term. It means less than or equal to. No more than is an inequality term. That means what? Less than or equal to. Now let's go to B. B says, complete the table by inserting the missing values of the cumulative frequency column. Now, ladies and gentlemen, cumulative frequency means that you're going to add the frequency going down. Cumulative frequency means you're going to add the frequency going down. So the next one is going to be 16 plus 26. Then what? 42 plus 37. 79. Then 79 plus what? 9. 88. And then what? 88 plus 2. 90. Ladies and gentlemen, that is how you complete the cumulative frequency curve, the cumulative frequency column. Cumulative frequency means you're going to add the frequency going down. Next, we're asked to what? Using a scale of 2 centimeters to represent 20 kilometers per hour on the x-axis, and 2 centimeters to represent and 2 centimeters to represent 10 vehicles on the y-axis. Draw the cumulative frequency curve to represent the information on the table. Ladies and gentlemen, to draw cumulative frequency, you need two values. You need the upper class boundary and you need the cumulative frequency. So the upper class boundary, 19.5, 39.5, 59.5, 79.5, 99.5, and what? 119.5. Those are the upper class boundary. How do we get the upper class boundary? We're going to add 0.5 to the upper class limit. We must add 0.5 to the upper class limit. Next. So, next thing to know is to draw up our axes. The next thing is to draw up our axes. You have your vertical axis and you have your horizontal axis. Your vertical axis and you have your horizontal axis. Now after that, the next thing we have to do is we have to label the axes. The next thing we have to do is we have to label the axes, and therein lies the trouble. What is the scale at the bottom? On the x-axis. Read it now, please. 2 centimeters to what? No, horizontal axis. Horizontal. to what? 20 what? Vehicles. Alright, listen this.
20 kilometers per hour.
20 kilometers per hour. Watch me. You have 2 centimeters to 20. Each centimeter on your graph sheet is divided into 5 equal parts. So here you have what? 2 centimeters, 0 to what? So 2 centimeters, this is 1 centimeter, 2 centimeters. Sorry, so another centimeter. Every centimeter on your graph sheet is divided into how many equal parts?
5.
Help me now?
5.
5. So now, this says 2 centimeters is equal to what? 20. When you divide, say if 1 centimeter is divided into 5, 2 centimeters will be divided into how much?
10.
Help me now?
10.
10. So now I'm dividing 20 units into how many equal parts?
10.
Into how many equal parts?
10.
So each minor division, 20 divided by 10, each of them would be what? 2. So if this is what? If this is 0 and this is 20, right here so it will be 18. Do you agree? Because it will be 0, 2, 4, 6, 8, 12, 14, 16, and then what?
20.
Each minor division is 2. Here's the problem. Between here and here, so can you plot 19.5?
Yes.
Watch me now. What is the upper class boundary?
19.5.
You can't plot it. You cannot plot it. So it means therefore we have got to have a different approach to this. Do exactly what I do. You can't plot it. There's no way you can pinpoint 19.5 between years and years. So you can't pinpoint it. So do exactly what I tell you to do. Are you ready? Are you ready? Call this 0.5. 1 centimeter, 2 centimeter, 19.5. No, sorry. Not yet. Call this minus life order. You'll enjoy vertical axis. Alright, fine, let it be. Call this 19.5. The next one is what? Then what? 39.5. How much is it going up by? Talk to me now, how much is it going up by? It's still going up what? 2 centimeters by what? By 20. But you didn't start at what? 0. You understand? Fine. Then now, this is what? 59.5. Why was it necessary to do this? Because there's no way you could have plotted those points accurately on the graph. You couldn't plot them. You could not plot those points accurately on the graph. You couldn't do it. Alright? Then now, sorry, actually, I'm sure your teacher has shown you how to do, showing you this. Do it like this.
Sir, I got the curve, but I just didn't do it like that.
You didn't do it like this, but actually there's no way you could have plotted those points. You couldn't plot those points. It's impossible to plot them. Anyway, let's go. The next one is what? 79.5. Then what? 2 centimeters again. Then what? 99.5. 2 centimeters again, and then what? 100 and what? 119.5. And the scale on the y-axis is what? The scale on the y-axis is what? 2 centimeters to 10. 10, 20, 25, 30, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, now I need to lose a high. I'm doing this over again. The highest the frequency went was 90. Alright, let it stay. The highest frequency went is 90. Let it stay. So over here we have cumulative frequency. And cumulative frequency here is what? Is vehicles. And down here, so it's the upper class limit. And this is kilometers per hour. Now, what are we plotting? Are you looking? We're plotting upper class boundary, x values, against cumulative frequency, y values. So 19.5 corresponds to what? Alright, are y'all seeing the point though where I tell you that you had to do it like this, because if you did it the other way, you could not plot 19.5. Because you have this little space which is 2 centimeters. If you divide it, you can probably reach what? 19, don't it? But I'm going to see how you divide it again to reach 19.5. You understand? You could not plot it. So because of it, you had to do it like this. Alright, 19.5 corresponds to what? 5. 5 is here. Next. 39.5 corresponds to what? 16. 39.5. Alright, can you tell me over here? On the vertical axis, each minor division represents how much vehicles? Over here, each minor division represents how much vehicle?
1.
Talk to me.
1.
1 represents 1 vehicle. So this is 10, 10, 11, 12, 13, 14, 15, 16. Then what? 59.5 corresponds to what? 42. 59.5 corresponds to 42. 40, 41, 42. Um, 79.5 corresponds to what? 79.5 corresponds to what?
79.
$75, $76, $77, $78, $79. 99.5 corresponds to? Corresponds to 88, 85, 86, 87, 88. And lastly, 119 corresponds to what?
90.
Those are the points you plot to draw your cumulative frequency curve. Alright, where are we at now? Now we need to draw the curve. Are you looking? Alright, it is a curve, so it must be done by a freehand. Draw it down to 0. Alright, so this is our what? Cumulative frequency curve. Are you with me? Alright, and everybody know that you must not draw these what? Little lines. You must not draw the lines to plot points. What did they ask for last? Or the last set of questions? Alright. Next it says what? Next it says, on your graph, draw reference lines to estimate the speed at which no more than 50% of the vehicles what pass. The speed at which no more than 50% of the vehicles pass. Alright, I'm erasing some of these lines because I don't want them to confuse answering the question. How many vehicles? How many vehicles? How many vehicles were in this survey? Or how many vehicles passed checkpoint? 90 vehicles. 50% of that would be what? Talk to me now. Alright, fine. Can I tell you what your graph represents? Your graph, at every point on your what? On your graph, at every point on your graph is a speed. At every point on your graph is a vehicle and the speed at which they pass the checkpoint. At every point on your graph is a what? Vehicle and the speed at which they pass the checkpoint. The vehicles down here pass the checkpoint at the what? Lowest speed. And the vehicles up here pass the checkpoint at the what? At the highest speed. Are you with me? Now, so let us find out what is the speed of the what? The 45th vehicle. Why? Because 45 would be what? 50%. Are you with me? So let's find 45. This is 40, this is 50. Between them is 45. This line you must draw. Anywhere you touch the graph, you don't draw the line down. And then now you need to read that point. Yeah. Come on, no. Yeah, but no, bring food to me in there, please. Hear me? How about you say and bring some food to me, please? You say one party. Two person. And maybe a Pepsi. Pepsi. Food and mutton. Alright, let's finish the question. Alright, listen, did you get a value? We already established that each of the minor division them is how much? Each of the minor division down here says how much? Each of the minor division down here says how much? If it's 2 centimeters to 20, each of the minor division will be how much? 2. Each of the minor division will be what? 2. We already did that. So let's go. Alright, for mine one would be mine is 60.5. That's mine. What is yours? Yours is what? You know you can't read 60 down there, sir. You cannot read 60 down there, sir. Each of them is 2. So sorry, this is not 2, 4. This is what? 60.5 minus 61.5. Yours is what? Each of the minor division them is what? 2. So this is what? 2, 4. 4 plus this is what? 63.5. Minus 63.5, what is yours? So this is mine. Mine is what? 63.5 kilometers per hour. So the 45th vehicle, its speed is what? The 45th vehicle, its speed is what? Mine is 63.5 kilometers per hour. What is yours? Very good. Then it says the speed. So I was to what? Draw the lines. I was to draw the lines. I. The speed. It says the speed. What is what? The speed at which no more than 50%. At which no more than 50% of vehicles pass checkpoint is 63.5 kilometers per hour. Whatever is yours, that is what you must write. Whatever is yours, that is what you must write.